Dr. Pushpito K. Ghosh obtained his BSc, MSc, and PhD degrees in chemistry from St. Stephen's College, Delhi, IIT Kanpur, and Princeton University, respectively. He is presently the K.V. Mariwala J.B. Joshi Distinguished Professor of Chemical Engineering at the Institute of Chemical Technology, Mumbai. He was the director of CSIR-Central Salt and Marine Chemical Research Institute, Bhavnagar, for 15 years. And prior to that, he served for 13 years at senior levels in ICI, both in India as well as the UK. He also served briefly at the University of Hyderabad and IIT Bombay. Dr. Ghosh has also been the chairman of Department of Science and Technology's Water Technology Initiative and member of several other national level committees. 3 years back, he reached the landmark of 50 US patents granted to him and his co-inventors. In the education field, like what inspired you to become a professor at ICT?
Yeah, see, ICT professorship came a lot later, you know. I think I liked the idea of being in research or being a scientist. I got this science talent research scholarship, and it also helped me to get into St. Stephen's College because that was the toughest college to get into. You know. So I went there, and the other very nice thing was that every year they used to have a summer camp, you know, where say there were about 35 to 40 people in the area of chemistry from all over India who got the scholarship. So all of us would go for a camp, you know, and where they would expose us to new ideas, new things which we had never heard of, and we also had to make a presentation, you know. And I don't know what happened to me, but I gave a lecture on entropy, you know, and somehow it was I think a good lecture that I gave, which aroused a lot of interest, and a lot of questions were asked by the Vice Chancellor of Rajasthan University, and then myself and another very good friend of mine, Sushila Matre, the two of us actually got the first prize in that summer camp, and that then, you know, certainly made me a little more confident because we're talking about the best students all over India, and then among those again to have been awarded the prize was obviously an indication that maybe I have an aptitude for original thinking and research, you know. So that was there, but that was still research. It wasn't education, you know, as such, which I was particularly concerned about, you know. But after I finished with my studies in the US and did my postdoctoral research, in fact, one of the very famous professors just passed away before yesterday. I got the message, and I was feeling terrible about it. But so I returned to India, and you know, I actually joined academics. I joined the University of Hyderabad. I had actually many offers, but that was an upcoming university, and where some of the professors from IIT Kanpur had actually begun working there, and they persuaded me to join. Now, this is one thing that I've always had, which is I always liked very low profile play, and so I thought I'll be in education. At that time, you know, someone asked me or told me that why don't you have a look at some of these industries? You know, they are really good research centers. Okay. And the two that I looked at, one was Unilever, and the other was ICI. You know, and ICI Research Center had a very attractive, catchy name. It was called Alchemy Research Center. You know, and actually that Alchemy was there were 4 or 5 companies, and the sort of acronym was Alchemy, and so that's how it was named. But for me as a chemist, you know, it was really alchemy that brought some excitement, into the job. And so I really went more into applied research. But what was interesting about that place was that they give amazing freedom, and they didn't really tell me you do this and you do that. And having come back from the US, having done very fundamental, cutting edge research in areas, obviously, I had some desire to do some things which were of a fundamental nature, and I did, and we published some really good papers around then. But I also realized that, when I've joined a place, I should be true to that place, and I should do things which would be of relevance and importance to them. And so I ventured into the study of explosives, which I'd never done, and there was a very interesting system, which was the next after dynamite, which was known as emulsion explosives, much safer explosives, civilian explosives, and ICI had invented those, and were the first to introduce it in India. And so I realized that it performs very well, but if someone asked me that is the science behind it well known, behind the structure of the explosive, etc., my feeling was no, it's not so well known. And so I started researching that. I had a very bright person working with me, and so we uncovered some of the structural features, which were important for things like rheology, to understand detonation, things like that. And then I at that point I realized that you actually need not have a very fine distinction between so-called fundamental research and applied research and technology and all, and they all are pretty much part of a continuum, and it's a question of doing things well, and doing research that matters, which is useful. Okay? And as someone later on, I much later learned that applied research is all about reducing the degree of empiricism in any art, whatever you do. And so that is something I quite enjoyed doing. And then later on, I went to England. I was looking after a part of the strategic research of ICI in England. And at that time, I used to collaborate with a lot of people from Oxford, Cambridge, University of Manchester, people in the US. And again, that brought me a bit closer again to academics, and not only academics, the best of academics. I mean, they were absolutely brilliant people. So I was kind of straddling both, for that way. And one thing I was sure about, that I possibly will make a good teacher, I mean, because, people used to like my lectures, and there was a time in Princeton, it had a very profound effect on me, that there was a Nobel laureate who was visiting. His name was Prigogine, and he's the one who got the Nobel Prize for non-equilibrium thermodynamics. And so Prigogine was visiting, and my professor, he was away that day. And of all people, he chose me, and he said, "Pushpito, you have to explain our group's research to Prigogine." I said, "Me? What will I say?" And he said, "No, you'll be able to do it." And so I actually spoke not only about my research, but on behalf of the entire group's research. And Prigogine really gave me a good pat in the back, and actually appreciated the whatever I said, my presentation. And so I knew that perhaps I have the capability of persuading others on what is important, what is unimportant, or and so So that was always there. I mean, I knew that I can perhaps become a good teacher, but then I was in applied research. So I met Dr. Mashelkar. Dr. Mashelkar is our chairman of ICT, as you know, and so he chancellor, and he told me that why don't you consider a job in CSIR, and I actually took that seriously because I was looking for maybe a larger canvas, to paint in, and so I said fine, I'll do that, and then he mentioned to me about Bhavnagar and how the lab is not doing well, and so he wanted me to go there and see if I can turn around that place, and now because I had started in University of Hyderabad education, and prior to moving to Bhavnagar, people in IIT Bombay, they wanted me to join the faculty there, and I started as a visiting professor because I could not commit to a full-time thing because I knew I might move, and so I was teaching, and later on, after I superannuated from Bhavnagar, then Professor Yadav called me and said, we've started this distinguished professorship in ICT, and we'd like to offer you this position. And so I honestly did not want to do much. I wanted to actually have a good time after retiring, but then I could not say no, and so that's how I ended up in ICT. So ICT was one of the subsequent academic positions that I actually had.
Sir, you have innumerable research papers and patents to your name. Is there any one particular research that comes to your mind as soon as someone asks you about them?
No, I was thinking about that, and I really struggled to identify just one, but I can name a few, which were probably important to me. I'm not going to discuss the things that I did, let's say in ICI. Okay, and I'll just maybe touch upon things in Bhavnagar, where I've spent the maximum part of my sort of career. But you have to remember also that I was the director of the lab, you see, and so as the director, I was not really just engaged in my own work. I was actually trying to feed ideas to all the disciplines, that existed there, and many of them were absolutely new to me. I mean, it's not that I actually had worked in any of those areas before. Okay, but I found that coming at things from the outside, the chances that you will ask questions which others who have been at it for a long time may not ask, they might miss out, is high. And also I knew that because I'm not in that area, so even if I come up with a absurd or provocative question, people will not necessarily mind. They might laugh behind their back, or behind my back, but they will not, to my face, say much about it. And so that actually led to some very, very novel ideas in mature technologies. And so, as a theme, if there is one theme that gave me great pleasure, okay, which I really feel happy about, it is that we could invent in seemingly mature technologies. Because people thought that those things existed for hundreds of years, and what can you possibly do in them, And like, for example, when we had the good fortune of working with Mercedes-Benz, and in Germany, and the reason was because my colleagues, were had done remarkable work in growing plants in sand dunes, in deserts, and in all kinds of wasteland, in saline soils, And so Mercedes were very impressed with that, and we created the kind of broad term. We said oil from wasteland. I mean that gave us great pleasure around 2001 or two. When we thought of that, and there was nothing particularly new as such in biodiesel. Okay, except at that time that we were extracting the oil from plants that were growing in wasteland, or had the potential to grow in wasteland. Because we didn't want any competition between food and fuel, so we were very clear about that. But then, when we started working on it, I soon realized that none of the people actually can make a good biodiesel. And yet, chemistry, if I were to just write down, is the most trivial set of equations that you can write. A triglyceride reacting with an alkali in the presence of methanol, and it will form biodiesel with some byproducts and things like that. And but I knew that nobody could, and then I delved deep into the subject. And what is the problem? Why is it? Like, for example, can you pour biodiesel 100% into a car and make it run? And Mercedes found that very interesting, and they said, really? Oh, that'll be great, if we can do it. Because nobody had done something like this anywhere in the world. And so we found extremely simple solutions, to the problem. And soon after we had succeeded, I see this newspaper report that Merck to run on meat biodiesel, around 2004 or 3. And it was an amazing feeling that here, we're doing some kind of a deep analysis of a potentially actually quite a simple reaction, and ultimately, you can pour it into a Mercedes-Benz engine, and then we took it to Khadungla Pass in Leh, and there are 3 Mercedes which were running, and in Germany we had about 15 journalists from Germany who came to see what's going on. So that created tremendous excitement all over the world, and that, I think one can rightfully say, was something that India gave to the world, and so it was wonderful. But it was still, I will say, away from the mainstream, of our activities, and I always wanted to also make sure that, our main activities like salt, marine chemicals, things like that, seaweed cultivation, which we were very famous for, that we will invent, and that we could come up with revolutionary concepts like a spherical salt. Like always people thought salt is cubic in structure. That we could make it round. And of course we made it round for a specific purpose, to make it flow more easily. And those were the kinds of things that we had in our mind. Or when some Jain priest came and talked to me, and they said that they did not like the idea that salt is produced in these salt pans, and there could be fish and things, along with the salt, or as it is being evaporated. And they said, साहब आप ऐसा कोई टेक्नोलॉजी डेवलप कर सकते हैं जिससे ये प्रॉब्लम नहीं होगा, And then I said, well, I mean, the sea water is of course coming from the sea, and there'll always be fishes and all. But at the spur of the moment, and because we were working on plants which were salt loving, and we were doing it for extracting some oils from those plants. But in the spur of the moment, I realized that those plants accumulate salt, NaCl, and I remember the joy I felt when I suddenly said vegetable salt, and we invented the world's first salt from a vegetable plant, I mean, which was extremely unusual. Inventions at the grassroots level, which helped people, and another was for which Dr. Abdul Kalam actually called me, was an invention, and today it's a very big thing all over India, if not all over India, in certainly in many states of India, which was that raising of seaweeds, and we were doing work with Pepsi, okay? And from these seaweeds you can get a gum, and that gum actually goes into all this pedigree food, dog food, cat food. It gives a chewy texture to food. And they were sourcing most of it from Indonesia, but Indonesia had these tsunamis and all, and so there was always a threat to the supply chain. And so they wanted to see if India could be a base for these kinds of products. And they came talking to us because we were in this area, quite well known in seaweed cultivation. And the first commercial cultivation of seaweed was raised by Pepsi based on our technology. It's a great feeling. But then what happened was something very interesting. These seaweeds contain about 90 to 95% water. So they're mostly water. Okay? And especially during the monsoon time, it was not so easy to dry these seaweeds. Okay? And so, at that time, we were always thinking that, is there another way to remove water from a seaweed, rather than just drying it like the way you dry fish? And one of my colleagues, Ishwaran, I don't know what made him do this experiment. He went and put the seaweed in a kitchen blender, and just mashed it up, and it just became like water, and it was like water. And Ishwaran came to me and he said, "Sir, I made this." I said, "For what?" And he said, "I put this in some mango plants and some other ground, some grams, green gram, and those seem to be growing very well." And so I said, "Ishwaran, Pepsi came to us for this gum, okay? They are not interested in gram and mango and all this." I said, "Where is that?" He said, "I don't know about that. Where is it?" Then I looked into that beaker, and I found minute specks, of a solid in that, floating in that liquid. And I had it filtered, and we realized that the gum is actually in the residue. And so overnight, within almost you can say 20 minutes, we had created two products, from that seaweed. One was the gum, the other was this wonderful fertilizer, and this became a big thing. Pepsi commercialized this, and Dr. Abdul Kalam came to know about it, and this was actually the second time he invited me to Rashtrapati Bhavan, and he actually spoke about it in his technology day speech, along with the BrahMos missile, which you might be hearing about nowadays. So these were the two technologies that he talked about. So I would say that these have given us great joy. Lot of fun we had inventing these, and it took us a long time then to get to the underpinning knowledge. What causes something? You can get an effect. You see, that this works. This is great. Why? How? Those kinds of questions to answer, it takes a lot longer. And so that's how we kind of married science with technology. And so these were some of those which gave us great joy.
So this makes me come to my next question, that a lot of your research is centered around inorganic salts and marine chemicals, as you told us right now. So can you elucidate more about these topics for our readers and all the research enthusiasts?
Sure. There's one, and which was the reason why I was hell-bent on wanting to make the best salt in the world. That's there, and that so many people have benefited from this technology was great. But it was also very, and there was already some work that was done where, the only source of bromine is seawater. And so all the plants that we have in India, they actually take in some form of seawater, concentrated seawater, etc., and extract bromine from that. As you know, bromine is a very important
Yes.
sort of reagent in bromination reactions. And this was again very important that, and as I said, the people who laid the foundation in bromine technology, I had the privilege of working with some of them, people like Dr. A.S. Mehta, brilliant people. And now what happened was that, when we were, because I knew how bromine is made, how it's recovered. Okay? So knowing the process and knowing the inorganic chemistry behind this, I realized that bromine is otherwise a very noxious chemical. It's not a good chemical to work with. Okay? And I realized that we make, in many cases, bromine from an intermediate, and that intermediate is a very friendly material. You can hold it in your hand. Okay? As you know, if you take bromine, put it in alkali, what does it? You'll get bromide and bromate, right? Isn't it? I mean, so if you just do the reverse, you can get bromine, right? So what happens is that one of the methods of extracting bromine, you actually make this intermediate bromide and bromate. And so at the time, what happened was that one of my colleagues had done work where he had taken this bromide and bromate. That had nothing to do with the bromine manufacturing technology. He had taken and he introduced the organic substrates, along with it, and he was able to do bromination, just like you would do with bromine. And so overnight, bromination became a very safe reaction, to do. And then when I was talking to Dr. A.S. Mehta and others, and I realized that this is the same intermediate that we get during bromine manufacture. And so, we immediately gave it the name green bromine, and it was a really wonderful technology that we developed. So that's how we got into bromine, revival of bromine, you can say. But the most pressing, the most serious issue was that, as you know, even today, India has a very serious problem of fertilizer availability. Most of our fertilizers are imported. Okay. We make much of the urea within our country, although even that about 30% is imported, and we were importing almost the entire few million tons of potash requirement from outside. Okay. And now, of course, in phosphorus, the same is the case because we don't have any phosphate reserves. So everything is coming from outside, either as a raw material or as a finished product. So potash was something which are very visionary people around 1941, they had written and said that for India, trying to recover potassium from seawater would make sense. Okay, and also because what happens is because we make salt, so the potassium gets concentrated, in the process of making salt, and so it seemed like a good thought, a good suggestion. Such technologies were known elsewhere in the world, starting from the days of Van Top. So it's not as if that wasn't known, but everyone got caught somewhere or the other, and we could not make progress. So from 1941 till 2000 and let's say 3, 4, we kept saying how important it is, it's how important it's for the country must do it, but we actually couldn't do much. It seems that it would be better to try and make potassium sulfate than potassium chloride, And potassium sulfate actually is more like a better suited product, to seawater. And he said it's a better fertilizer, and why don't you see, if you can make potassium sulfate instead. Potassium sulfate is a known product as such, So I, literally again, I was traveling by plane somewhere, and I think the flight was delayed. And in the airport, I'd worked out the scheme, which will make for a viable technology, or so I thought. And I came back to the institute and asked my colleagues, can you have a look at it? And we came up with a beautiful technology, And that technology was licensed, and the first plant was set up producing about 100,000 tons of potash. So that's how we got into potash, because potash is again one of the constituents from that you get from seawater. So bromine, potash, salt. Those three became important, and the integration, which actually helped us to really come up with this great potash technology, was that India also has a lot of steel plants, etc., and requires a lot of refractory materials for its ovens, furnaces, and the best refractory material is magnesium. And magnesium also comes from seawater. So I realized that both potash and magnesium are important, and it was in integrating, marrying these two, that really this technology emerged. But then I think that it was always in the back of my mind, as I told you, that I wanted to do something for the larger good, because there you're working for a company, you're doing great things, no question about it, but it's confined to a company, and also, I realized, see, there are different kinds of researchers, okay, and there's nothing to suggest what is a better research and what is a not so good research or whatever. Like, there are some people who all their life can work on one problem. Those are the people who typically get the Nobel Prize. They worked hard at a problem from beginning to end, and they mastered it. Okay. There are others, like, I find interest in many problems. I just don't want to be confined to one problem. And it's also been my undoing, okay? Because undoing in the sense that, you see, if you invent a lot of things, and if the market pull is not growing at the same rate, then most of it just lies in the shelf, as I found out. And in fact, that's been one of my biggest laments, that what's the point? What did all these technologies and all these patents ultimately deliver? How many of them were actually commercialized? That number is relatively small. And so whereas I think each and every one of those should have been commercialized, and I felt all of them were important. Okay? But it was because of this interest that I had that I really wanted to do work in many different areas.
Beautiful quote came to my mind right now, that challenge and adversity are meant to help you know who you are. Storms hit your weakness, but unlock your true strength. So what has been the most challenging time that you faced in your entire career, and how did you overcome it?
Yeah, I think, in terms of technical challenge, if I have to say, there were certain urgencies, for coming up with certain products and things like that. And it was very frustrating not to be able to come up with it in time. And that was always a challenge that I left not only to myself but to my colleagues, that this is an important challenge. In terms of personal challenge, there are. It's really not so much of a challenge for me, but what happened was in 2007, I was actually appointed as the Director General of CSIR, and I was interviewed by all the famous scientists, CNR Rao, Bharat Ratna, and the Cabinet Secretary and everything. And the first time, two of us, what we decided was another person called Dr. Prakash will become the Director General, and I will be the Additional Director General. And subsequently, Prakash fell ill, and they re-advertised the position, and then I was selected as the Director General of CSIR. And it was all over the newspapers, that Pushpito Ghosh to be the new Director General of CSIR, and but that never materialized, or something got in the way. Okay, and although after the interview, it was all finalized and everything, but whatever. I mean, I don't know what were the reasons, but I never finally got the appointment letter. Let's put it that way. Okay. Now, it was to some extent, for me, actually, it was not such a big setback or anything, because I honestly felt that probably CSIR had something to lose from it. I mean, I really didn't have that much to lose,
Are a definitive example of convergence of academia and industry. Which one do you incline towards more?
Yeah, as I told you, I mean, I have been one of the critics, of this segmentation of people as people in fundamental research, applied research, technology development.
Yes, sir.
Okay? And it's my good fortune, that I'm teaching the course on innovations in chemical technology, which I developed in ICT, and where I teach the works of Nobel laureates and others. And as part of that course, I also teach about a book. It's called Pasteur's Quadrant. And much later on, when I was teaching this course around 2015, I came to know that the person who wrote this book, Donald Stokes, actually was a professor right opposite our chemistry department in Princeton. And he was a professor in a very famous school called the Woodrow Wilson School, of International Learning or something. And Stokes had written this book where he actually derided scientists, for this classification. And he felt that the best scientists, and he epitomized Louis Pasteur as the most ideal scientist. And Louis Pasteur always worked on practical problems. Of course, that was a bit later, after he had invented optical activity and things like that. He accidentally got into microbiology. But Louis Pasteur, people would come to him because their sugar beet is not fermenting into ethanol. What should I do? And so he was trying to solve their problems. And in trying to solve their problems, he laid out entire new areas of science. That's what Louis Pasteur did. And so I would always, and not maybe if you had asked me this question 40 years back, maybe I would have given you a different answer. But today, with the kind of serious concerns around sustainability, which there are, that I cannot see myself not working on an applied research problem. I would really want to do something that contributes meaningfully in the area of sustainability. And if in the process we unravel some good science, then so be it. That will be wonderful. It will be like an icing on the cake. Okay? But I would not, just for the sake of very fundamental research. I was doing that. I was doing extremely fundamental research. Like things like, what is the origin of tyranny? Where did it come from? I mean, even such profound questions, we are trying to answer at one point. Okay? But today, I will certainly work much more on these kinds of sustainability problems. So that would be my priority.
So today, especially as your student, I feel so honored to be interviewing you. As someone whose career has been going on since the past so many eras, you have not only seen India grow and develop as a country, but also contributed majorly to it. So where do you think India stands on the global front in regards to green and sustainable technology? And where do you think the chemical industry is headed in the next 10 years?
Yeah, that's a very good question, and probably extremely important, the question that you've asked. I must say I'm a bit pessimistic. Okay, I'm not actually as optimistic as many of the others are. The reason is because if you look at, let's say, if you look at the world as a whole, and you look at all the products that we use, ours is a carbon world. It's all carbon, whether it's the clothes or the medicine, or even if you take fertilizer, and that today even sulfuric acid is coming from H2S from fossil fuel, or that it is natural gas, which is the feedstock for making urea, and ammonia and urea. It's not just nitrogen and hydrogen; they are coming from natural gas, and that India is importing 85% of its crude oil and natural gas. And how can you, and even today, with the way things are, where so many people are still aspiring for a better standard of living, how are you going to make it happen? So it's a very, very serious concern. Okay? Even if, let's say, there is some future breakthrough, I'm not seeing it as of now, although there has been a lot of good work done in the area of nuclear fusion, and possibly in the next 30 to 40 years, it should materialize, maybe earlier. But I'm a bit skeptical because when I was in Princeton doing my PhD, and Princeton was the place where some of the earliest work on nuclear fusion was carried out. And I used to hear that it will happen 75 years into the future. That was the plan, 75 years. I'm talking about 1975, so I'm talking about 2050. That's what it is. They seem to be on course, to achieve that, though it may not be Princeton, it could be somebody else who will achieve it, maybe China. But you see, in any case, if there is no solution to the energy problem, then many of us will not survive. I mean, that's the truth. Okay? Assuming that there is let's say a breakthrough in the area of electricity from nuclear fusion, solar and wind, I cannot see in India it contributing more than 20%. I find it impossible, to believe. Maybe 30%, but certainly not more than that. So there's going to be a huge gap. Fossil fuels have been given another 30 to 50 years maximum. In any case, within about 20 years, you'll probably have serious wars with who will get the last bit of fossil fuel. There are going to be battles fought. Let's face it. Yeah? And India may or may not win that battle. So I think that my biggest concerns would be things like fertilizer. Because look, one thing that the pandemic has taught us is that you actually need very little to survive. You don't need so much. Most of the things that today we are producing are all goods which are nice to have things. They're not essential things. You can get rid of them. If it comes to that, if it is what you require is you require medicines, you will require food, okay, and fertilizers are a very important part of that story. You require water. So those are the kinds of things that will make us survive, and at least will see us through till there is some fresh breakthrough which will come from people like you. You all are the ones who have to now come up with those earth pioneering, kind of initiatives over the next maybe 50 years. That's what you have to do. Okay? Now, India, as you know, has jumped into this manufacture, okay? Because it was a marriage of convenience. The West wanted to get rid of those, okay? Because they didn't want to have emissions and greenhouse gases, etc., at their doorstep. So it was merrily outsourced to China and India and other countries, and we were also very happy because it meant higher GDP and exports and everything. Okay, but we are also paying the price because we are not really doing it with the cleanest of technologies, and so there are going to be huge problems. That India will be faced with. One will be our fundamental limitations of natural resources. We don't have feedstock. And second is technology, where the really pioneering technologies. I'll still say, whatever people might say, I'll still say that we are working with a reverse engineering Me Too mindset. We are not really pioneers. We've got to face it because what happens is that it's become very fashionable whenever people say, why isn't Indian research and R&D doing better? And people will say, oh, because we're not spending enough money. That's not true. That's because scientists are being deceitful. They don't have the guts to say because we have not been smart enough. That's why. Okay? And so we've got to be much, much smarter. And for that, you'll have to have much greater confidence in yourself that you can do something really new and original. And you have to show it. And there have to be others who have to actually applaud what you're doing. You see, but if you don't do that, and if you're pulling at cross purposes, you're not going to happen. So I see huge opportunities for green technology, no question about it. But I also see that it will require a different set of people and a different mindset. It will require people like you all, the bold and the adventurous, who will make it happen.
Now, I would request you to please give some words of wisdom for the young and budding researchers who draw their inspiration from you.
As I told you, I mean, don't listen to me. Huh? I'm the last person you should take advice from, because as I told you, I was myself not in that sense an ideal or a model student, But I do want to say a few things, One thing, and I want to put that right on top, is that enjoy what you're doing. That's very important. You must enjoy, because if you don't enjoy and if it is just a drag, and you're going through the motions, the chances that you really end up doing anything very worthwhile are low. So I would say that enjoy. And by the way, it need not be only science. You could be into something else. In fact, I must tell you that that I used to. I was in the final interviews of some of these UPSC exams. Where we selected these IAS and IFS officers. And prior to that, I was also on the board of IIM Ahmedabad. And so I've seen people, very brilliant people, who had started off as a maybe a chemical engineer or some other sciences, physics, things like that. But they went on to do something else, and they have done extremely well. And nobody should point a finger and say, "Hey, you studied this. Why didn't you become a chemical engineer?" Or it's not mandated. You should do what you enjoy doing and really enjoy it and try to do it well. So that's, I'd say, one of the most important things. I would say that be true to yourself. Don't try to be a hypocrite. And don't try to please the world. Okay? Most of us, I find, are being politically correct. Okay, and we are not actually speaking our mind. We are not being true to ourselves. Many times I feel that one of my undoings, so-called as per the rest of the people, has been that I've not held the status quo position. I've said things which are different, which people may not have always liked, but it's not bothered me at all whether people like it or not. I'll say that don't take shortcuts. That is one thing I have learned. I learned that lesson. Oh, you asked me what did I as a child? I'll tell you what I learned as a child. How I learned not to take a shortcut. It was in the sports field, okay? And there was one game where we had to run and then we had to go under the bench, and crawl and then again come out the other side, and then whoever reaches the other side the fastest or something, And I remember I did some mischief and I jumped over the bench or something, but I did not do what actually the rules prescribe. And I won the prize. Okay? Little did I know that the principal of a school, a very famous man, Clifford Hicks, Anglo-Indian, was watching from the terrace, and he called me and said, "What did you do?" I said, "Why? I won the race." He said, "Yeah, by jumping over the bench, not under it." And I learned my lesson. Do not try to cheat and do not try to be smart or smart. And so don't take shortcuts. That's one of the things. And the sooner one learns these lessons, rather than learning it when you're a middle-aged person, and you've cheated a lot of people, and then learning is not worth it. Try to learn it as soon as possible, and don't take shortcuts. And especially in science and technology, shortcuts don't work so well. Another little advice that I would have is, I would say, work on worthy problems. There are, whether we like it or not, there are problems which are worthy of pursuit, and then there are useless problems. Because nobody, whether you solve it or don't solve it, doesn't make any difference. Just don't avoid such problems, which are And I always tell everyone that I would much rather fail in a worthy cause. It's a perfectly all right if I fail. I have no problem. And I've always said that to everyone who has worked with me. I don't mind, if you have not been able to achieve the result. But you're just trying to show up with some papers and things like that, which have no consequence whatsoever. I don't see that as a very significant accomplishment. So I would say work on worthy problems. Don't take shortcuts. Be very honest to yourself. You don't have to be honest to others. You just need to be honest to yourself and enjoy what you're doing. Have fun doing it. I think that and of course keep abreast of things, because that's one of the things I learned. It's so easy to get obsolete in today's world. But let me also tell you that just as everybody is in this catching up mode and wanting to always be up to date, I have many times, completely withdrawn myself, and I don't want to listen to what all is going on. I like to just think pure thoughts which come from not knowing too much, and some of my best ideas have come from that. So those are all the little things that I've done.
Surely, sir, there is no shortcut to success. With this, we come to an end. Today, I've got to know some inspiring experiences and learnings that I will cherish forever. Sir, it has been an absolute delight to hear you talk about your journey and experiences. As Thomas Edison rightly said, if we did the things we are capable of, we would astound ourselves. I hope this session was as enriching for our viewers as it was for me. Once again, thank you, sir, for taking out your time of your busy schedule for this interview. And thank you, Bombay Technologist, for giving me this opportunity.
Well, let me tell you, I thoroughly enjoyed this interview. And you've done such a magnificent job. And I would like to, also acknowledge, Ekta and Devraj, because I know that they were pursuing this, constantly. And I was absolutely amazed by, the deep thinking that has gone behind the kind of questions that you have asked. And I have really thoroughly enjoyed talking to you.
Thank you, sir. Thank you so much.
Thank you. Thank you.
Thank you so much, sir. Thank you. It really means a lot to us.
But I honestly enjoyed it a lot.